Hi guys, welcome back. Now we discuss our main lecture. The exponential relationship of the current I to the voltage V holds over many decades of current, a span of as many as 7 decades. A factor of 10 to the power 7 can be found. This is quite a remarkable property of junction diodes, one that is also found in bipolar junction transistor and that has been exploited in many interesting applications. Let us consider the forward current voltage relationship in equation 4.3 and equate the current I corresponds to a diode voltage V1. I1 is equal to ISE V1 over VT. Similarly, if the voltage V is V2, the diode's current I2 will be I2 is equal to ISE V2 over VT. These two equations can be combined to produce I2 I1 is equal to E V2 minus V1 VT, which can be rewritten as V2 minus V1 is equal to VT ln I2 over I1, or in terms of base 10 logarithms V2 minus V1 is equal to 2.3 VT log I2 over I1. This equation simply states that for a decade factor of 10 factor of change in current, the diode voltage drop changes by 2.3 VT, which is approximately 60 millivolt. This also suggests that the uh, 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 diode current voltage relationship is most conventionally plotted on semi-log paper using the vertical linear axis for V and the horizontal log axis for I. On obtained a current straight line with the slope of 60 millivolt per decade of current. A glance at the current voltage characteristic in the forward region figure 4.8 reveals that the current is negligibly small for voltage smaller than about 0.5 volt. This value is usually referred to as the cut in voltage. It should be emphasized, however, that this apparent threshold in the characteristic is simply a consequence of the exponential relationship. Another sequence of this relationship is a rapid increase of I. Thus, for a fully conducting diode, the voltage drop lies in a narrow range, approximately 0.6 volt to 0.8 volt. This gives rise to a simple model for diode where it is assumed that a conducting diode has approximately a 0.7 volt drop across it. Diode will different current ratings, different areas, and correspondingly different IS with exhibit the 0.7 voltage drop at different currents. For instance, a small signal diode may be considering to have a 0.7 volt drop at I is equal to 1 milliampere, while a higher power diode may have 0.7 voltage drop at I is equal to 1 ampere. We will study the topics of diode circuit analysis diode models in the next section. Examples also given with solution. Since both Is and Vt are function of temperature, the forward IV characteristic varies with temperature as illustrated in figure 4.9. At a given constant diode current, the voltage drop across the diode decreases by approximately 2 millivolt for every 1 degree Celsius increase in temperature. The change in diode voltage with the temperature has been exploited in the design of electronic thermometers. Graph diagram, block diagram, temperature dependence of diode forward characteristic. At a constant current, the voltage drop decreases by approximately 2 millivolt for every increase in temperature. Exercise. Now, topic 4.2.2. We discuss in this topic about reverse bias region. In upper topic we discuss about forward bias regions. Now here we discuss some characteristic of reverse bias region in this lecture. The reverse bias region of operation is entered when the diode voltage V is made negative. Equation predicts that if V is negative and a few times larger than VT 25 millivolt in magnitude, the exponential term becomes negligible small compared to unity, and the diode current becomes I is equal to minus Is. That is, the current in the reverse direction is constant and equals to Is. This consistency is the reason behind the term saturation current. Real diodes exhibit reverse current that, though quite small, are much larger than Is. For instance, a small signal diode whose Is is on the order of 10 k plus minus 14 ampere to 10 k power minus 15 ampere could show a reverse current on the order of 1 nanoampere. The reverse current also increases somewhat with the increase in magnitude of the reverse voltage. Note that because of very small magnitude of current, all these details are not clearly evident on the diode current voltage characteristic of figure 4.8. Next, reverse bias region topic discuss detail in next lecture. Don't forget to subscribe my YouTube channel MK Tech.